Hey everyone, let's get started this morning, afternoon, or evening, whenever you're on here. But let's get started by making sure we're logged into Clever. So, welcome to week 5, live lesson or lesson 9. We are going to continue talking about how energy and matter changes as we change matter. And I'm really excited to continue working through with you all. Some reminders, make sure to check your assignments on Google Classroom for comments, recommendations, and feedback so that you can return that work and get that work all caught up and turned in. Continue working to get caught up if you got behind. I'm accepting that work. I want you to be successful, so please keep putting in that effort and you will be rewarded. Remember to watch your videos all the way through on Edpuzzle, and if you were not in the live lesson, that's why you should be here right now. Please do not turn this Edpuzzle in on Google Classroom unless you were in the live lesson or unless you have done this Edpuzzle. You're not going to get that one by me. Please make sure that you're coming into Teams on time so that we can get started and get the most out of our 30 minutes together. Remember our 2 mutes and a boot policy, as well as the ability to use the chat. I hope that you guys can be in a live lesson sometime soon because I really appreciate the ability to be on there live with you and working. So this week's assignment, you should have already done the week 5 preview, number 21. Remember that any of these assignments or posts that have a number in front of it, that hashtag, and then a number, that is a required assignment. So that Edpuzzle is required. This Edpuzzle that you're watching right now is only required if you were not in the live lesson version. So after we get done with this, you have 2 assignments that you should be working on, a reading comprehension activity about fusion in stars, and then our phenomenon reflection question that is related to that article and the work that we've done today as well as last week. I do want to let you guys know about a change that will be happening. Some of y'all are going to be shifted into some new classes with a new teacher. His name is Mr. Carroll. He's really awesome and he's super excited to get started with you guys. So just be on the lookout there might be some changes happening because we are in desperate need of a new teacher to make sure that our numbers are right. Thank you guys for your work, RIP, RBG. And yeah, let's get started. So we're continuing to look at the first phenomena and understanding where all energy and matter in the universe comes from. And so we're doing that today by thinking about the differences between physical, chemical, and nuclear reactions. So first thing that needs to happen, we're going to watch this video. Maybe. As we watch this, take in the information.
Nuclear energy harnesses the power inside atoms by changing their structure. The energy we use in nuclear power plants is called fission. Nuclear fission releases energy by splitting atoms. Nuclear fusion happens when 2 lighter atoms are combined into a larger one. The sun is fueled by nuclear fusion. It takes extreme amounts of pressure and temperature to fuse or combine atoms, so we on Earth don't have any way to produce large amounts of energy by nuclear fusion. But scientists are working on it, because nuclear fusion uses elements like hydrogen, so there's an almost unlimited amount of fuel available, and that could lead to unlimited cheap energy. For more information about nuclear energy, check out the Science Trek website for this.
All right. So, based on that and our understanding of nuclear reactions and nuclear energy, is this statement true or false? True or false? Nuclear energy involves changing the structure of an atom. So that is true. Nuclear reactions that release nuclear energy result when the nucleus, the middle of an atom, is actually changed to form a different atom. All right, next question. Is this statement true or false? Nuclear reactions produce less energy than chemical reactions or physical changes. This is false. Nuclear reactions release so much energy, way, way, way more than chemical reactions or physical changes. And lastly, is this statement true or false? Fusion reactions inside of the sun essentially fuel life on Earth. This is true. Those fusion reactions release a lot of energy, particularly in the form of radiant energy, which is light, and thermal energy, which is heat. The light and heat that is released from the sun is what allows photosynthesis to occur and plants to grow, as well as keeping the temperature of the earth at a suitable temperature for us to survive. So these nuclear reactions, remember, occur in the nucleus when an atom is split or fused together. So you start with one type of atom. At the end, it's a brand new atom that is either bigger or smaller. And when you do this, there's so much stored energy in the nucleus that a lot of energy is released when those nuclear connections are broken. So the common examples and the ones that they spoke of in the video are fission and fusion. Nuclear bombs and nuclear power plants usually utilize fission because it's pretty easy to split an atom. They take large atoms like uranium or plutonium, they shoot a neutron in them, and they split apart. Fusion occurs mainly inside of stars because that's one of the few places where there's enough pressure and high enough temperature to allow atoms to come together and to not just like form a new molecule, but to literally form a bigger atom. Now, this is completely different from a physical change where there isn't really a whole lot of energy released. The matter itself is not changed into anything new. It just is changed in its outward appearance. So the size or the shape might be changed. There might be a change in the phase of matter that the substance is in, but we're not making any new molecules and we're not making any new atoms. So what you're looking for to identify a physical change is if there is a phase change, so moving between solid, liquid, or gas. If you see the size or the shape changing, if you see mixing occurring, but without forming anything chemically new. And a kind of rule of thumb is if the physical change, if the change can be reversed, it's most likely a physical change. Okay, so the examples here that we talked about the other day and that hopefully you were able to brainstorm include crushing a can, boiling water, freezing water, breaking something, mixing something, chopping something, shredding something, dissolving something. These are all examples of physical changes. Now, a chemical change, you actually do have a new substance being made. You're not making new atoms, we're not quite to that level, but you're making new substances because the atoms that were bonded to each other are breaking apart and forming new bonds in different ways. So what you have at the beginning are the same atoms as you do at the end, but the way that they're bonded to each other and arranged, that's what's changing. And in a chemical reaction, there usually is more energy that's released than a physical change. Think burning something, but it's not as much as a nuclear change. So the evidence that you should always be looking for, one is a temperature change. So if something gets way, way colder, or if it gets hotter, if it releases energy, that should be a sign to you that this is a chemical change. So any burning of some substance, there's obviously heat that's released there. If you see a change in color like we do in this bottom corner, or right now with the leaves out as we have them change during the fall time, that is the sign of a chemical reaction. If you see bubbling or fizzing or notice a smell that wasn't there before, that suggests that a gas is being produced like we see here, and that is also a sign of a chemical change, or the formation of what is called a precipitate that occurs when you mix two liquids together and get a solid. All right, so some example, any sort of cooking of anything or baking, the mixing together of ingredients would not be a chemical change, but the actual process of baking is. Anytime you have bubbling or fizzing or fire or changing of color, like when something rusts, or someone said an example of a chemical change was the fart, and you're not wrong. When you eat food and digest it and then gas is released in the form of a toot, that is definitely a sign of a chemical change. All right, so our major piece of the lesson today is to be identifying some changes as either physical, chemical, or nuclear, and then thinking about what is the evidence that tells us that that is the type of change that is happening. So a GIF is going to show up on the screen. You're going to identify if it's physical, chemical, or nuclear, and you are then going to provide a piece of evidence to back up why you chose what you did. So here's our first example. So is this melting of an ice cube a physical change, a chemical reaction, or a nuclear reaction? Okay, and what is the evidence to support that? So what we see here, this is a physical change. That water is in the solid form. The bonds between those water molecules are being released as they move apart and become a liquid, but you still have water. It is just in a different phase. Next, what about this one? Which type of reaction is it, and what is your evidence to support that? So this is a chemical change. We have anytime we have the burning of something, there is heat being released, and you can tell that heat tells you that there is a chemical change that is happening. We can't undo burning something, right? So it is a chemical change. What about this one? So this is a physical change. There is no new substance that is being made. We still have wood at the beginning and we have it at the end. It is just a little bit smaller. It's broken into two pieces. So that tells you why this is a physical change. All right, what about this one? Is this a physical, chemical, or nuclear? And how do you know? So this is a nuclear reaction. And the key that you should think about with this is that there is clearly a crazy amount of energy that is being released. And that is a huge sign for a nuclear reaction. All right, what about this? Physical, chemical, nuclear, and how do you know? So this would be a chemical change. Now there's clearly a lot of energy being released here, but it is not enough to be a nuclear reaction. Again, if we had nuclear reactions happening in wide open spaces like this would be really bad for us. So the light being given off, that's a form of energy that's being released. We see this, the smoke. It looks like it's hot. That would tell you a chemical reaction. All right, a couple more. About this, physical, chemical, or nuclear, and why? So this would be a physical change. The reason it's a physical change is because we still have the balloon and we still have the water at the end. The form that it was held into is a little bit different. We've just changed the shape. What do we think about this one? Physical, chemical, or nuclear? So this is actually an example of a fission reaction where a large atom is split apart and a massive amount of energy is released as the atom is split apart. The nuclei is changed. If you see the nucleus or the atom being changed, that should signify a nuclear reaction. All right, and our last one. This looks like a chemical change, right? It looks like the temperature might have changed. There's a new substance that was not there before. It's expanding out and signifying that there must be some sort of gas being released. Good work, you all. I will do the last one. Never mind. All right, so if you could reflect on today's activity, tell me one thing you liked, one thing you didn't, one thing that was easy, and one thing that was hard. All right, and so I'll leave you with this. Here are your tasks that you should be doing after you complete this video. There is a reading comprehension about fusion and stars. Please do not just read or do not just Google the questions to find the answers. I want you to actually read the article. It's short and all of the answers are in there. And then you have your phenomenon reflection question for this week. Why are stars important in the creation of matter and energy in the universe? Use the sentence structure. And I think that's it. Good luck and see you guys in the next live lesson or recorded lesson. Thank you. Reach out if you have questions. Bye.